This is, if you agree with everything you hear today, then we're doing it wrong. You should hear things that you disagree with. That's the point. It's the point of this is to get you thinking about a variety of topics. So, the host of this event is Thierry Klein. He's the president of solutions research at Nokia Bell Labs. At TechUnited, we look to build really strong relationships with some of the larger technology-focused organizations around the state. And breaking into these walls can be very challenging, and you often need a really strong champion to help build those relationships. And I could not have found a better champion in Thierry Klein. Can you please help me welcome him to the stage for our next discussion? Thanks. Oh, we even sat on the right sides. How about that?
First.
Yeah, is the mic on? We're good? So, I am immediately going off script, but for those, we've done a lot together, so I have a decent sense of what's happening at Nokia Bell Labs. But for those who perhaps, how many people are here for the very first time?
Wow.
Most. In one or two sentences, what do you do here?
I think I'm going to pick on what PJ said. I think we're creatives. We're creatives in the technology. So how many of you had Nokia phones at some point?
How many still do? Wait, there's a hand up. No, really? For real? You still make the phones?
No, we don't make phones anymore, but that's how everybody still remembers Nokia. So we basically built the world's infrastructure, communication, networking technologies and infrastructure. So everything that connects your phones, everything that is the backbone of the internet, whether it's on IP technologies, optical technologies, satellite communication, subsea, data center connections, and so forth. So basically, if you do anything in the information technology space, whether it's you're watching Netflix video at home, you go on Facebook, or you send a text, or you make a call, I think 95% of the chance you touch Nokia technology at some point. And the dirty secret is you probably don't know it. Bell Labs is really the research part of Nokia right now. This year we celebrate 100 years for Bell Labs. We've always been the research part of, I say, the mother company. With all the M&As in the telecom industry, we've always followed the M&As, but we've always been the research part. And in particular, what I do, we actually have in Bell Labs 2 sister organizations. So we have, for the last 5 years, we have 2 co-presidents of Bell Labs. My dear friend Peter Vedder is leading one part. I'm leading the other part. I'm not sure Peter is here, so I'm going to say I'll lead the cooler part. But we basically look at the new technologies, whether it's AI, Web3, blockchain, new device technologies that support the current business and future business of the company, but also have the potential to grow the business into new areas and new domains.
What's something that Nokia Bell Labs is commonly known to have been the inventor of?
Well, I think the most
These are meant to be rapid fire, by the way,
okay.
Thierry. Stacey's going to start yelling.
Thanks for telling me. I think the single, still most impactful invention of Bell Labs is the transistor, 1947, right here in this building. I think every day we try to beat that, but I think it's still the most impactful
kind of high bar
invention. Yeah, and all of you have probably 18 billion transistors in your chip in your iPhone or Samsung phone, so very impactful.
And what's something that is a lesser known invention that's come out of this facility?
My favorite, because I'm an information theorist by training, is information theory in 1948 by a gentleman named Claude Shannon. He really provided the mathematical foundation for how much information you can send between point A and point B in a reliable way. And I think that just opened a lot of the information technologies of how do we connect, how do we communicate, and how much information can you send.
Yeah.
But I'm biased.
A little. That's all right. Anybody who here has heard of Claude Shannon? Interesting.
All right.
How is Nokia Bell Labs using AI today?
So I think it's AI is in it's of course internally in the Nokia operations. We look to use AI internally, but we really think of AI in the networks, and then how do networks connect the physical world and digital worlds, and how does that connection between networks and AI outside of networking and connectivity. But a lot of our work is to bring AI into the networks, whether it's wireless or optical or IP technologies. We really see the opportunity for AI through the different network technologies, but also through the entire life cycle of a network, from design to operation, management, customer care, really through the entire life cycle.
Could you dumb down like, why does anybody, what's happening before AI, what was happening in the network, and what is AI enabling that's making it more cost effective, faster, smarter, better?
Yeah, sure. So I'll give you one example.
I'm the dumbed down person, so you pretend it's just me and you. What do you got?
So I'll give you one example, and I'll tie it to a personal story. When I started several years back, this was the 3G days, we used to do drive testing on the networks. And you drive test around, and you collect measurements on your network, and then you make some offline calculations, and you change the configuration of, say, your wireless base stations. And I can tell you, if you ever do drive testing in New Jersey, and you sit around in the neighborhood with your laptop, make sure you have a letter from your boss that says you're actually doing work and you're not snooping on people. That came very handy 20 years ago or so. So you did drive testing, and it's very offline calculations, and then you send somebody to a tower, you change the configuration on the antenna that you see along the highways, and then off you go and you drive test again.
But just that little nuance, you send a person to a tower, like plug in a piece of hardware to a piece of hardware, a person on a ladder.
Yeah, you change the antenna, right? So that's the 3G days. Then we started to get into, well, this should really be done by algorithms and math, and self-optimizing networks became a big thing in the 2010s or so. And so that's the evolution where you don't drive test as much, but you have these networks and have embedded algorithms. But it was still algorithmic. Now we're looking at, and you get performance improvements. Now we're looking at AI coming in to learn really the traffic patterns, where people during the daytime, where people at night, how should we optimize this network with AI? And just one concrete example where we look at AI to optimize the performance of a network during daytime and nighttime, where your traffic pattern changes, and you don't want all your network capabilities turned on when you don't have the traffic. So we used AI, and we can show 10 to 20% improvements on the energy consumption while still making sure you support all the calls. So that's one example where the manual part couldn't handle it. The algorithms hit a certain limitation, but AI allows you to unlock a little bit more performance, in this case, energy efficiency.
So what's the difference of AI in the network versus a network for AI?
So I would say the dirty little secret, or the blind spot of AI, is really that networks are critical to unleash AI. Everybody talks about AI for whether it's digital applications or more and more in physical applications. PJ talked about the cars and the trucks. But you see AI in all the physical industries, whether it's manufacturing, logistics, utilities, and so forth. AI fundamentally is driven by data. Data tends to be very distributed and decentralized. It's in all of our phones. It's in all the machines and sensors and devices. So it even starts with, how do you collect all this data, and how do you bring it to a data center where you would train your language model or your AI model, and then how do you run those models? So networks are just foundational to really unlock the power of AI. So we do need high-performing networks. The networks to support AI are very different from the networks that you have today, because AI drives not just more traffic, but also drives very different types of traffic. So you need the network to support the AI, but then of course you want the network itself to be as high-performing, as energy efficient as possible. So AI in the network to make that as efficient, and then networks to support all the AI in the, say, adjacent industry, non-telco industries.
What's the competitive edge that a Nokia Bell Labs could provide to that process? Like, does that become a commoditized service, or are there differentiators there?
No, I think there's, you mean in the AI in network or network for AI?
In the AI in network.
No, absolutely, because we take sort of, in Bell Labs, we always take the 10-year view, like future back. Where do networks need to go? And so we're not just looking at some low-hanging fruits you can do today, but we're looking really at fundamentally how you bring AI natively into the network. Very often that requires long durations, because you might need standards change and so forth. But it's by taking that long-term view of, how do I make the network fundamentally more AI native, rather than making incremental changes. And if I may pick up, it's great to go after PJ, because he had so many analogies from the arts, and I resonate with a completely different field, but you talk about the sequential process of the creating a movie. My analogy in the networking field is, when we look at the signal processing that you would do on mobile network, it's actually human design that said there are these different steps. And I don't want to get into the technical details of what they are, but somehow 20, 30, 40 years ago, we decided that those were the sequential steps that we needed to do to send a bit from A to B. Then we can start taking the AI ML approach and saying, I'm still keeping the sequential steps, but now I'm replacing each step by an AI ML model. And that gets you certain gains. But talking about an AI native network means I'm just getting rid of that human design that it has to be these steps. I'm putting an entire AI ML model on the transmitter and on the receiver, and I let both of them figure it out. And it's iterative because as the network changes, as the user traffic patterns change, these two models on the transmitter and receiver just have to adapt and figure it out. So your example, it's a very different field, but the way you described it, you know, I saw immediately the parallel. So next time, if we have an event again, I want to go after PJ.
Sure. Why? You said if? What if? No if we have.
Oh, when.
When. There we go.
There you go.
I'm always selling theory. I mean, come on. The last time we were actually on this stage, when I didn't force you to commit to hosting this one, we talked about the efforts to send a network to the moon. And part of the topic of this title is around the physical impact of AI. So, you know, you mentioned briefly the autonomous vehicles. How do you see the evolution of AI on the physical world, and where do you see some of the most near-term opportunities?
Yeah, I think AI in the physical world is probably the next revolution in AI. And it's really about how do we understand the physical world around us? How do we understand what's going on in the physical world? How do we improve it? And whether your goal is productivity, efficiency, or safety, or sustainability, I think those are typically your four goals. You do want to capture the physical world, whether it's in physical world, I mean any environment like this. I mean an enterprise environment. I mean a factory, a harbor, a port, a utility grid. You want to capture that physical world, and then you want to reason on it. You want to extract the meaningful information so that you can then improve whatever your metric is. And I think we are only scratching the surface on that. We've primarily looked at document summarization and maybe writing poems or creating PowerPoints. But I think the AI in the physical world is really just at the beginning.
Oh, I'm sorry, go ahead.
No, and then it's how do you interact with that? And how many of you have heard of digital twins? There you go. So digital twins, you probably think it's just a cat drawing of a machine, but how do you build digital twins that are large-scale digital twins that understand the physical world in real time? So the first digital twin you might think of is the engine of an airplane. Okay, you can look around, you can look inside, and you can manipulate it. That's great, but how do you build a digital twin of an entire airline or an entire airport? And then how do you keep that up in real time? And then you need to capture that physical world. You need to understand what's going on because you don't want the detail on everything. Maybe you need to zoom in and out on the detail of that digital twin of the airline. But then you need AI tools to help you improve. Maybe you want to reduce delays, and we all know we could use delay reduction in Newark. But so you need to capture it, and then maybe you make decisions and these systems become so complex, and you're going on this loop of capturing the physical world, understanding it, and then optimizing it in such fast pace that you really need tools and AI tools to do that, because no human can really handle the complexity or the speed of that cycle. We've always done this, capturing, understanding, improving. That loop is just a general process. All of you are going through that right now. You're listening to what Aaron and I are saying. You try to make sense of what I'm saying, and maybe you ask a question. So you're going on that cognitive loop right now, but we're running this loop at much larger scale in the physical world and at much higher speed. And that's why I think networks are important to enable that, and AI is really the engine that drives that loop.
What do you think will be the most tangible? You have this very macro view. You mentioned earlier your favorite topic is information theory. I'm trying to bring some practical, like what are some, autonomous vehicles seem like an obvious one. Are there other applications of AI in the physical world that you think will just start to touch our lives in the very near future?
I'll go back to my previous answer. I think that would be fantastic if you can really, any world that you go into, any physical environment, you can instantaneously capture a digital representation, get understanding, And
For
we're
what
not-
purpose though? Like why, there's some technology now it's fun because you can, but doesn't seem to have much of an application. Can you expand on that into what you think the useful application would be there?
Yeah, I think worker safety in a factory environment, for example. Right? You have machines, you have robots. It's a very complex environment. You have people walking around that are maybe not connected. You don't track them with devices. But how do you make sure that they're safe when you have machines, human and machines collaborating in the same space? So how do you capture that knowledge, and how do you know that this person now wants to go here because they're trying to execute a particular task, but I have robots that are running the same way. So how do you improve that? And that would be one safety example, but I think if you're looking at sustainability or productivity or efficiency, you find lots of examples. But it's that real-time understanding, it's not just taking pictures, it's really understanding what is in your space, how do things behave, and how can I query it, how can I ask it questions. So one project we worked on in the labs, we call it Industrial GPT, because we're not very creative, so we go ChatGPT, Industrial GPT. And it's really, we build up this...
I think PJ's AI system could have done better than that.
Yeah, no doubt, no doubt. So we capture physical world, but then you can ask it intelligent questions and it can reason on it. So one very simple example is you talk to a robot and saying, I'm seeing smoke. And the robot then understands that it had built up this world knowledge, and it correlates that smoke probably means fire. To help with fire, I need a fire extinguisher, and I know where the fire extinguisher is, and it goes to pick it up. So it's that kind of reasoning and understanding where I'm not asking it, where's the fire extinguisher? But you ask a natural human question, and it has this understanding of the physical world on what is happening, but also what the reaction should be to, in this case, solve the fire problem. But that's a very small example, but it's that capture between the understanding and the action that will be really exciting, I think.
I know you're really passionate about space exploration.
No.
No, not
How
at
do
all.
you know?
How do you think AI evolves? And we shared in our last discussion your desire to be someone who has a chance to maybe travel to space. Do you think that becomes required? So the question is sort of twofold. How do robotics play a role? But in particular, knowing your passion here, how do you think robotics, space exploration, and AI intersect in the future?
So I do believe that we'll go to the moon. I do believe we'll go to Mars. I don't know the exact time frames for Mars. But we're going back to the moon. We establish more of a permanent presence on the moon. We can discuss why and how and so forth. But if you think of a permanent presence on the moon with an industrial operation and an economy, a lot of that has to be robotic driven. You're just not able in the next 10 years, 15 years to send enough astronauts to do all the functions that you need for fully operational or permanent presence of people on the moon. So it will be very much robotic driven, and that's where the robotics come in, that's where networks come in, and a lot of this will then be AI driven because astronauts will not be able to handle all the machines. So these machines have to be self-coordinate, self-managing, self-operating, and really execute, say, a resource mining or drilling task. The other part where AI and analytics, I think, come in is at some point we will be collecting so much information on the lunar surface or Martian surface in the future, it is not practical to send all this information back. From the moon, you can still send information back and you have about a 1.5 second delay. If you go to Mars, it takes you 20 minutes to just laws of physics. There's nothing we're going to do about that. You're not in a position to send all the information back to then analyze it on Earth and then send a command back. So you will need to do a lot of processing in space. You will see data centers in space. You will see data centers. Already now people are talking about data centers in Earth orbit. You will see data centers and AI on the lunar surface and or the Martian surface. And we only bring back that information that we really need here, but everything that is locally relevant will be locally processed. So that's another area where I think AI will really come in.
You have a unique inside view on robotics and the physical applications of AI in particular. And a common dialogue are people's fears around what might happen as these robots, machines become more self-enabled. Are you optimistic or pessimistic?
I am cautiously optimistic, if I can do an in-between optimistic and pessimistic. I think we see the transformative power of AI. I think what everybody's worried about AI right now, 5, 10, 15 years ago, we were worried about robotics and automation. So I think everybody is concerned about it, and that we should have our guards up and we should be vigilant. I think the positive will be there. We have to make sure that we're really applying AI to the meaningful problems and not just AI for AI's sake. I think it's important to keep responsible AI principles in mind when we build the systems. So the business rationale, the responsible aspect, but what I'm more worried about is the speed of transformation and how fast we change. And all the other revolutions before happened over generations, and our society and our educational system could catch up. I think that's the part that concerns me the most of, is this speed of transformation so fast that we are not able to adapt and we're not able to even adjust our education system for the new jobs of the future. So I'm optimistic, but I'm worried about how we get from here to there and the speed of the transformation.
We're over time, but I'm just super curious, since I know you have a son who I think is in college, maybe recently graduated, but I know he's interested in being a pilot. What, if you had a clean slate, could say, hey, I think you should study this, what would you recommend to parents of people entering the workforce?
Oh, not what I would tell my son, but I would tell people in general. My son, I would
Is
still
he
tell
here? He's joined us some events before.
Yeah, he joined us at the Moon event last year. He's in Florida right now. He's so passionate about aviation, so if he would ask me right now, what do you want to do? I'd say, go follow your passion. By the way, I don't think we'll have, he might be the last generation of pilots, but I don't think in his generation we'll have self-flying planes. So he's probably safe, but who knows, maybe we won't be talking about self-driving cars and trucks, we'll have self-flying planes at some point. No, I think the important thing is just follow your passion, be curious about the world around you and follow your passion. And if you force yourself in a field or a direction that is not natural to you, that you don't enjoy, that's a really hard time to be in. So just follow your passion.
That is the opposite of what I thought you were going to say.
What do you think I was
I thought you were going to say become like the world's best mathematician, because that will open all the doors you'll ever need. That's a common talk track right now. And in this building, that wouldn't have been surprising, but that's great. Yeah. Follow your passion. Another thing I sort of disagree with. Can we get a huge round of applause for Thierry Klein? Thank you very much. Thanks for coming. All right, keeping it moving. So.